So now we're going to get into the area and perimeter of some particular shapes. So we're going to start with parallelograms. We defined these in the last lecture. It's a shape that has two equal sides opposite each other. We just don't have to have the guarantee that there are right angles. And so if we look at a parallelogram, we have to kind of introduce a new label. So base is kind of the same as it was before. Height is the same as those, same as triangles, but it's different from rectangles. In fact, that the height, the h that is perpendicular to my base, is not the same as just one of the sides of my parallelogram. So that height is going to be different from the side, and we call that side the slant height because it's the slant of the parallelogram. So watch for that. You just got to be careful when you're trying to find the area of parallelograms for that reason. And then the nice thing about parallelograms is the formulas are essentially the exact same as they were for rectangles. For area, you do base times height, and again, that's height, it's not slant height. And then for perimeter, you do add up all of the distance around the outside of the shape, or you add the two B's and the two S's if you're doing the formula, and that will get you the perimeter. Now for trapezoids, if I'm trying to find area and perimeter of a trapezoid, that gets a little bit more tricky. So here's our trapezoid. The definition of a trapezoid is that you have two parallel sides, and that's essentially it. So it is kind of one of the loosest terms for a quadrilateral. And so if you have a trapezoid, you are going to have one base and another base, and then you are going to have a height. And again, that height has to be perpendicular to the base, or B1. So the area is going to be, you essentially find the average of the two bases. So you do base 1 plus base 2 divided by 2, and then you times it by your height, and that's going to get you your area. Or another way that I've seen the formula is h over 2 times b1 plus b2. And then again, if you're trying to provide perimeter, you just add up the distance around. I'm not even sure I wrote it down on this slide. So to see in practice, let's say that we are dealing with a trapezoid here. We're looking to paint two walls in an attic that is shaped as below. If paint costs 0.65 cents per square foot, how much will it cost to paint both walls? So again, we have to be a little bit careful as we're reading it, as that we are reading it as a word problem. This shape that we have displayed is only one of two walls. So essentially, whenever we get towards the end, we just have to make sure that we are multiplying by 2. So this is a trapezoid. It's a little bit weird to picture because it's kind of turned over, but it's a trapezoid that has a base of 3.8, and another base 2.4, and then the height is 5 feet, because although it's the side of the trapezoid, that side does happen to be perpendicular with my base. So I'm going to start by finding the area. I'm going to use that formula. I add the two bases, I divide it by 2, I times it by the height. That gets me an area of 15.5 feet squared. But that's only the area of one wall. So like I said, in the directions or in the question, it tells us that we are dealing with two walls of this type. So we have to multiply that area times 2. Gets me 31, and then we have to think a little bit and say, okay, that's my feet squared, that's my total area. I want to figure out how much it's going to cost me to paint both of these walls. So I know paint costs me 0.65 cents per square foot. So I take my total area, I multiply it by the cost of my paint, and I know that it's going to cost me a total of $20.15 to paint it. Now moving into circles, we're going to start by kind of jotting down a few formulas. So here is a circle. The center is labeled C. D is the diameter, so that's the distance across the circle that goes through the center. And then the radius is the distance from the center to the edge of the circle. So if I'm trying to find my diameter, well, since the diameter is the total distance all the way across, it makes sense to think, okay, well, I just multiply my radius by 2 and I can get my diameter. Or if I have my diameter, I can divide it by 2. That will give me my radius. And then I'm sure you guys have at least heard of what pi is, if not know kind of the first 3 digits of 3.14. Well, the cool thing about that There's a ton of cool things about it. But one thing in particular is that was discovered a really long time ago, because what people were doing is they were taking circles and saying, okay, I have my circumference, I know my diameter, and then they would put the two over each other and get this weird number 3.14, blah, 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 blah. And they kept doing this and it kept showing up. So that's where pi comes from, is it's always going to be the circumference of a circle divided by the diameter. So turning that around, if I want to find the circumference of a circle, I do 2 times pi times my radius. Now that's the more common way of finding circumference. You can also find it by doing pi times your diameter. I'm fine with either. That works just fine. And so then my area is going to be pi times my radius squared. And so I would just take my radius, I square it and multiply it by pi. And there is, again, another way to kind of write it. I've seen pi times diameter for circumference. Outside of my course, I don't think I've seen anyone use this alternative formula for area of a circle. All that being said, it works. You can just take your diameter, square it, times pi, and divide it by 4. Now, let's work through some examples. Let's say I have a circle here, and I didn't really explicitly do this in the drawing because I think I probably did it in paint, but we're going to say that my radius is 5 feet, that arrow starts at the center of my circle. So to find my circumference, I just do 2 pi r, my r is 5. So I multiply that, and I get that my circumference is 31.4 feet. Now sometimes it's actually more beneficial to kind of just leave it as 10 times pi. Usually if I'm dealing with a word problem or it's an application problem, I do want you to kind of round it to an approximate answer, where if this question was just find the area of a generic circle and they don't give you any units, it's perfectly fine to just do the 2 times 5 is 10, and that gets you 10 pi, because that's actually the exact answer. Okay, for my area, I do 5 squared times pi gets 78.5 feet squared. In this case, I have a circle, and I'm given the diameter. So if I want to use the formula 2 pi r and pi r squared, I have to do an initial step of finding what my radius is. So if my diameter is 1, my radius is going to be 1 divided by 2. So that's where that 0.5 comes from. And then just plug that in for my r. So my circumference is 3.14 meters. And then if I want to find my area, in this case, I use the alternative formula. So instead of converting here, I'm going to use that pi times d squared over 4. All that being said, you could convert it, since we already did. We converted, we know that our radius is 0.5. You could use the classic pi r squared. Either way is fine. You're going to get the same result as me, which is that the area is 0.785 meters squared, or if you're rounding 2 digits, 0.79 meters squared. Now here's kind of an interesting shape, and this is what I like to build to in my courses when I deal with area, is once you're kind of equipped with these formulas to give you a shape that's actually not just a general circle or general parallelogram, but to kind of expand on that and for you to figure out, okay, maybe I don't know what that shape is, but could I break it down into shapes? So this shape, what I have is I have a almost like a pill that the straight part of the top part is 5 inches all the way across, and then the width of this pill-like object is 4 inches. So what I'm going to do is I'm going to start by finding the perimeter of my shape. Well, I mentioned the straight parts of my shape are just 5 inches, so that's good. And then you might notice that the outside parts that aren't straight are actually circles. So in order to find the perimeter around those circles, I'm going to have to find the circumference. So I have 1/2 on the right side, 1/2 on the left side. So I'm going to find the perimeter, or the circumference of one of the half circles by doing pi times my radius. And then I'm going to do pi times my radius, which is pi times. So I'm going to find the circumference of one of my, we call them semicircles or half circles. I'm going to do pi times my diameter, because I'm given my diameter of 4. And then I'm going to divide it by 2 because it's a half circle. And well, now I have another half circle on the other side. So I'm going to do pi times the diameter of that, which is also 4. And then I'm going to divide it by 2. So if I add all of these up, I get that my perimeter, which probably isn't technically the correct term, but the distance around my shape is certainly the correct way to think about it, is going to be 22.56 inches. Now to find my area, I'm going to do a very similar kind of concept of breaking it into 2 shapes. So it's a pill, so the center is actually going to be a rectangle, and then it's just going to be a rectangle with 2 half circles on the edge. So if I can find the area of my rectangle, and find the area of my 2 semicircles, I can just put them together and solve. So the area of my rectangle is just going to be 5 times 4. That's the center part, the straight part. So what's left is the 2 semicircles. So if I push those 2 semicircles together, I have a single circle that has a radius of 2. My diameter is 4, so my radius is 2. So I do 2 squared times pi. That's given me the area of both the semicircles added to the area of the rectangle gets me a total area of 32.56 inches squared. Okay, a couple more examples. I want to find the area of a shaded region, another kind of classic way to look at shapes. So we have this almost kind of a washer or just a circle where we pop out the inside circle, and we want to find the area of that shaded region, that region in blue. Well, we've never talked about how to find the area of a washer. I'm sure there's formulas online that will do it directly for you. But really what I want you to do is say, oh, recognize I have a big circle and I removed a small circle. So if I can find the area of the big circle, I can find the area of the small circle, and I can subtract the 2 and I will get the shaded region. So to find the area of my big circle, I'm going to use that kind of weirder formula, the pi times diameter squared over 4. Or if you prefer kind of the more regular way to approach it, you would do pi times 3 squared. So I know the area of my big circle is 28.26 feet squared. The area of my small circle, they give me the radius already. It's 2.5 inches. So I just square my 2.5, multiply it by pi, and then I get 19.63. By the way, while I'm thinking about it, when you're doing this in your calculator, be careful about order of operations. So for the area of the small circle, I would actually do 2.5 squared first in my calculator, and then I would multiply by pi. If you don't follow that order, you're going to get a much bigger area than you should get. So make sure you're dealing with the exponents before you're dealing with multiplication. And then, as I said, I'm just going to subtract the 2. I find that I get 8.63 feet squared for the area of the shaded region. So one more example. Again, the shape looks super weird. This definitely doesn't look like a circle or a parallelogram or a rectangle or anything like that, but it does look like a piece of it. In fact, it's a 1/4 of a regular circle. Like if I took that piece and rotated it 3 times, I would be able to kind of create a disc like I saw above. So to find the area of my big circle, I would do pi times 9 squared, and then since I'm only doing 1/4 of it, I divide that by 4. That's 63.59 meters squared. And then to find the area of my small circle, I would do pi times 6 squared, and since I'm dealing with 1/4 of a circle, I would divide that by 4 as well, giving me 28.26. Now if I subtract the 2, I find the area of that shaded region to be 35.33 meters squared.